Alrighty, so we are tackling the laws of probability, section 14K in the IB Math Studies book, if you're following along. So, you see this crazy, ugly looking thing here. It's actually much simpler than it looks. So, the laws of probability, we're talking about the probability that event A, this is an event, union B, that means that the probability of either of these things happening is equal to the probability of A plus the probability of B minus the probability of their intersection. Okay? So in other words, the probability of picking up, this is back to our sushi and burrito situation from last time. So we have 7 plus 6 is 13 plus 10 is 23 plus 4 is 27 people. Okay? These folks like sushi, these folks like burritos. So the probability of picking something in here is 7 plus 6 plus 10 all over everything, which in this case is 27. But that's the same thing as 7 plus 6. Probability of 7 plus 6 over 27 plus 6 plus 10 over 27 minus the probability of this, because you don't want to count the 6 twice. This would be counting the 6 twice, so that's why we have to subtract it, because it's the intersection is counted in both of these. Okay? In the same way, the probability of either this or either A or B, but not both, either this or this, but not both, this is the both right here, is the probability of A plus the probability of B minus the probability of both A and B. So it's the probability of this plus the probability of this minus this part, because this would be the both. So these are related. Just wanted to expose you to how this is written. Just another way to think about it. When you actually get down to the problems, they're easier than they may at first seem. Okay? Now, this is also related to another idea, mutually exclusive events. Events that are mutually exclusive if they cannot both happen. So, this is just a vocabulary thing. I'm either going to jump off a bridge or I'm not going to jump off a bridge. So, the intersection is 0. And the union would be 1, right? I'm either going to do it or I'm not. So if I union them both, it's either going to happen or it's not. So that's definitely, both of those things, one of those things is definitely going to happen. But since they don't have an intersection, the probability of, both of them happening is 0. So the Venn diagram in this case, the Venn diagram in this case doesn't intersect. That's the idea, okay? So if this was J and this was N, there's no intersection. The intersection is 0. Okay? So then this is just a weird algebra thing, fiddling around with this. So the union, which remember is 1, is the same thing as the probability of J plus the probability of N minus the probability of the intersection of J and N. But remember, this is 0, so this doesn't even matter. So it's really just the probability of these two. The probability of these two have to happen, so it has to be 1. Actually, a better Venn diagram might be the one that doesn't have the space outside of the two circles and looks like this. This is J, this is N. It's got to be either this or this, and there's no intersection between the two. Okay? So given that background, I want you to try this problem here. May or may not actually even use some of the stuff that we just talked about. So go ahead and pause it, take a look, see if you can do it. Okay? Alright, so you're back. I hope you have tried this, and now you are checking your work. If you haven't tried it yet, pause it and do it. Okay? So we have a group of 20 animals, 12 have tails, 14 are brown, 2 animals do not have a tail and are not brown. Randomly selected animal, 2 probabilities. So we need to create a Venn diagram for this. Okay? So we have tails, brown. Okay? 20 animals total. 2 animals do not have a tail and are not brown. So that's here. Okay? In our U, neither T nor B. So that's 2. So what's left in here? Well, 20 minus 2, we have 18 left in here. 18 are in here. And of those 18, 12 have tails. So that means in this circle here is 12. 18 minus 12 is 6, so this has to be 6 here. Okay? So then I can go with brown. 14 or brown, here's 6, so this has to be 8. So then if we have 8 here, and I know that 12 have tails, here's 8 of them, this has to be 4. I double check. 20 animals. 4 plus 8 is 12. Oops. 4 plus 8 is 12. Plus 6 is 18. Plus 2 is 20. Good. 12 have tails. 4 plus 8 is 12. 14 are brown. 8 plus 6 is 14. Good job. 2 don't have either. Yep, looks right. So, randomly selected, what's the probability that it has a tail? Well, here's tail. There's 20 total. 4 plus 8 is 12. So it's 12 over 20. Okay, we can simplify that, dividing the top and the bottom by 4. That would be 3 over 5. Again, in IB Math Studies, either of these is fine. You don't need to simplify. Has a tail, given that it's brown. Again, if we're talking about just the browns, it has to be within this. So given that it's brown, it has a tail. Well, here are the ones that have a tail of the ones that are brown. So 8 have a tail. How many are brown? 14. So again, we can simplify that. 4 over 7. All right? Hope you learn a thing or two. Toodles.